So what I have here is a diver, micro brand diver called Prometheus that I picked up about a year ago. It's got a Miyoto 9015 movement, and I want to show how accurate these can run and how to regulate them. They're 28,800 beats per hour, very similar to the ETA. So I'm going to try to do this as quick as possible, not to be long-winded. And I like to wear diver watches on the palmar side of my wrist, just because the bigger, clunkier ones I like in that position. So I'll take a reading first at a dial-up position. This is on a full wind. So here we are running 5 seconds fast, 3 seconds. There you can see our amplitude and the beat error, 51 degrees of lift angle. So we need a little bit of adjustment here, but that's dial up. Now these are a little more, I'm going to flip this over to dial down and take a reading. These are a lot more, they change with positioning, they change quite a bit as far as the regulation goes. I just flipped it over, so there we have an initial reading 0. We lost a little bit of amplitude, and we still have some beat error. So what I'm going to do, and what I like to do with divers, I regulate them dial down. Always dial down, because that's usually how it ends up on my wrist. So I'm going to come in here, I'm going to flip it over, get a picture of a good shot of that movement right where the regulator is. The ETA is a lot easier to regulate because it's got a fine-tune adjusting screw to really fine-tune the accuracy of it. This movement, the rotor only winds in one direction. It's unidirectional, not omni. One direction only. So let me see if I can get a good spot here. And I'm going to regulate this dial down right here in this position where I like to set them. Let me get a focus on here. Let's see. We have 3 seconds slow, 4 seconds slow, 268, 269 degrees, 0.3 millisecond beat error. So I'm going to give that, this little lever here, I'm going to give that a nudge in one direction. I don't know which way it needs to go. There's only one way to find out, and that is to give it a nudge and see where our reading ends up. I'm not going to keep flipping this back to the reading. I'll just read them to you because that'll take more time, setting it up, focusing, and all that. I honestly don't think I moved it enough. So there I moved it, and now it's jumped to 0.4 milliseconds. So we're going to come back the other direction and just give that a movement. If I can get this to stay in place, here's what I'm going to do. I'm going to put a piece of Rodeco right there, if I can, to hold that in place. I got two, well, I'm going to need two of them. There's always something getting in the way, isn't there? All right, come on. Okay, there's a piece of Rodeco holding that rotor from being a bit of a nudge. Of course, it's stuff like this that adds time to these videos. So, let's start over, so to speak. We're going to come in and nudge that lever. wow. Takes a fair amount of pressure and then it pops to get it to move. It's very tight. It's a pretty movement as far as Geneva stripes. Not as nicely decorated as the Swiss counterpart, the ETA. See, it looks like I went too far. Now it's at 0.5 milliseconds. Probably went too far. So, coming back around. That was a tiny bit of movement. Now we're at 0.4. There's a little bit of movement there. 0.1. So I think I need just a tiny bit more to get it to 0. I like to get these as close to 0 as possible. It's not always a guarantee. I'm just watching the dial here, or watching the screen. And I think I might have gone too far. Let's see what that shows. Each time you do that, it will change your basic rate. Yeah, it looks like I went too far. Oh, yeah. Okay. Just when I think I can make a short video, it doesn't happen. Now we got to come back. And it's basically trial and error. Back and forth, back and forth. Eventually I'll get it. Maybe not. Okay, we're at 0.1 and 0 milliseconds. Okay, I'm happy. 0.0 milliseconds. However, it is running 12 seconds fast. So let's go to our other lever, and we're going to slow this down a bit. And it's going to come in from this direction, I believe. Yes. This direction, I'm going to nudge it, and that'll slow it down. I did move it a little bit. It may not have shown up, but it did move. Probably too far, but that's okay. It does have a scale, plus or minus. You can see right there in that little indicator, it's pretty much sitting in the center. So we're still at 0 millisecond beat error, 267 degrees of amplitude, 14 seconds slow. So I did move it too far. I'm going to come back and just give that another tiny nudge. I don't know if I moved it. It felt like I did. It may not have shown up on the video. It did, because now it's at 10 seconds. Don't know if that was enough. Okay, -7, so we're 7 seconds slow. 6 seconds. 5 seconds. 265 degrees, 0 millisecond beat error. Ah, that was too far. I could feel that was way too far. That was definitely too far. 16 seconds fast. I'm just going to come back here. Hopefully we'll get this close. Close to 0. I can't expect it to always stay at 0, but it's a good starting point. Leave it at 0 and keep track of it that way. Okay, now we're back to 3 seconds slow. 10 seconds. As you can see, this can take quite a bit of time compared to a Swiss ETA with the fine tuning of the screw. I do have a video showing that as well. Don't know if that was enough. These are, what am I trying to say? I don't know. I haven't taken one of these apart yet. I've had the balances out of them. They look simple to work on. I can't imagine them being that difficult, considering it's just a one complication movement as far as having a date wheel. It does have hacking seconds, which is nice for time setting. Okay, here we go. We're going to let this run for a little bit, and maybe I can make up something to talk about as this is running. I have 265 degrees, 0 milliseconds, and let's go right to it, because I think I'm just going to leave it at that. Okay, there's +2, 268 +1, the beat error, +1, +2. I mean, I could probably tinker with this to get it to 0, but that might take me another 10 minutes, so I'm not even going to bother. I'm going to leave it at that, but what we're going to do now, we're going to flip this over. I can just turn the watch holder, and let's see how much that changes. So there's dial up. Right away, I just changed it. Dial up. It's going to take maybe a minute to get back to its original amplitude. Maybe not. Not as many degrees, close to 300 as the Swiss. Although 271, I would say, is pretty good. You can tell by that line, the beat error is 0. And this is dial down. I'm sorry, dial up. So if this was on top of your wrist, I would actually change that to 0 instead of +7, but I like it at the other side of my wrist, the palmar side. So let's see what happens when we do stem down. So I just gave it a little rotation. Here is stem down. Going to give that a second or two to come in. It's losing a little bit of amplitude. That would make sense because there's more pressure on the staff of the balanced, so it's going to put more pressure on one side of that staff and jewel than the other. It should recover pretty close to 270. However, it is running quite a bit faster. Certainly within spec. I don't know what these are in spec. Also notice the beat error is off a little bit. Perfectly acceptable and to be expected in that position. You can see that's losing amplitude. Probably not going to get up to 270. But like I said, I always pick one. I could do all kind of calculations and figure out what would be ideal. I'm just not that anal about it. So let's turn this around. Now we're stem up. I basically check these in 4 positions, and I think the specs on these for accuracy is ±20 seconds per day. So we are well within specs for that. We're getting a little bit of better amplitude with the stem up. However, I don't expect it to stay that way. Again, I just do dial down, set it, and forget it. That's just me and my preference. So here we are, back to dial up. Just to give you let's do a shot of this movement. You can see some Geneva stripes there from machining. Unidirectional rotor for winding, hacking seconds. This watch is fairly heavy. It's a pretty good clunky diver, but I like these clunky divers. It's not crazy big. I think it's 44 millimeter. not too thick, but it keeps really good time. It's got outstanding lume. I mean, the lume is incredible. It's like a night light at night. So this is pretty much all I'm going to say about this. So getting back to where this is, right now we just flipped it to dial up. We'll give you one last shot here. Dial up. There we go. 0 plus 2 deviation. The amplitude appears to be coming up, and our beat error, that's pretty good. I'm not gonna mess with that at all. The line, it's tracing a nice line across there. So that's our little Miyota 9015, and how well it regulates. You can get these pretty close. It just takes a little bit of time. I hope this helped. If anything, it entertained you for a few minutes. And one of these days, I'm going to rip into one of these and tear it apart and service one, which I think is probably not wise to buy one of these and then have somebody service it, because you can buy replacements for $50. You can buy the entire movement, put it in, regulate it, you're done. But a watchmaker may charge you $100+ to service one of these movements, and that would be pointless. Just buy a new movement, have your watchmaker or yourself put one in. So hopefully this helped, and we'll see you next time.